Today we're covering the notes for arithmetic sequences. So first thing is that an arithmetic sequence is a sequence in which or where each term can be found by adding or subtracting the same number to the previous term. The common difference piece. This is that consistent amount that is either added or subtracted between the consecutive terms. The term number. This is the position of the term in the sequence. And this is read as A, big A, sub, because it goes down, N, the value of the nth term in the sequence. So, in subscript form, so A sub N, each term in the sequence is written using the subscript shown in the position of the sequence. So this is first term, second term, third term, fourth term, and the nth term. Think of this as your class periods. This is first period, this is your second period, your third period, your fourth period, and then your nth period. So whatever class period we would have to think of, okay? So the first term of the sequence, that's number 3. The second term of the sequence, that's number 5. The third term of the sequence, that's the 7, okay? I think I'm going to box these in a different color for each one. I think that looks best. So now D, and by the way, this would be your fourth term, okay? So D, this is the common difference. This is how much it's changing by each time. So 3 goes to 5, we would add 2. 5 to 7, we would add 2. 7 to 9, we would add 2. So our common difference here is 2. That's how much it's changing by each time. We are adding 2 every single time. Okay? So here, this is function form. So remember, f of n, this is function notation, is the value of the nth term. The term number n is the input, and the term value, the a sub n, is the output. So same thing. For my first term in the sequence, this is -4. So my input is 1, my output is -4. For my second term in the sequence, oh my bad, this is actually the third term in the sequence. So don't do that. This is the third term, which is this one. That's -8. And this is looking for my fourth term in the sequence, which is this last one, -10. So the one that's not brought up here is my second term in the sequence. That's -6. So the first term, the second term, the third term, and the fourth term. So now we look at common difference. How much is this changing by every single time? Well, we start at -4 and we go down 2. Then we're at -6 and then we go down 2 more. And then we're at -8 and we go down 2 more and we get -10. So we are going down by 2 every single time. So one of the questions that we like to ask with this is, the two different type of questions we ask is, what are the first terms in the sequence? Or one of the questions we like to ask is, what is the 30th term or the 40th term? So here's how we deal with it when it's the identify the first 3 terms of the sequence. So it says that my first term is 6. So my input, or my x value, is 1. My output, so this could be like your f of x or your a sub n, your output is 6. Okay? Now it's also telling me my common difference is 5. So if I'm looking at my second term, my difference is +5. So I would add 5, and 6 plus 5, that's 11. My third term in the sequence, again, I would add 5. 11 plus 5 is 16. So my first 3 terms in the sequence are 6, 11, and 16, because it's my first term, my second term, and my third term. Again, it says identify the first three terms of the sequence for f of 1 equals -2 and d equals -4. So the first thing I'm going to do is I'm going to make a table. And again, this could be your f of x, or this could be your a sub n, okay? But these are your outputs. This is your input. My first input is 1, okay? My output is -2. Then when I go to my next one, my difference here is -4. So I'm going down by 4 each time. So when I go to my next term, -2 going down 4, that's -6. Here's my third term. We'll use pink. Again, I'm going down by 4. -6 minus 4 is -10. So my first term is -2. My second term is -6. My third term is -10 because this is going down by 4 each time. So this is my function. Now, the recursive formula, that's kind of what we're doing here. The recursive formula, each new term in the sequence is based off the previous term. Okay. So the first term in the sequence is always based off the previous term. We take the previous term, whatever it is, we add the difference, and we get the new term. So in order for me to figure out my third term here, I had to go back to 11, add 5, and get to 16. In order to figure out my second term here, I had to go to my starting place, which was -2, subtract 4, because that's my difference, and get to -6. So I need my previous term in order to apply it to the difference. So this is the previous term. This is that common difference, kind of how much it's changing by. And this is called the nth term, the term that we're looking for. Same thing here. This is the nth term. This is the previous term. And this is the common difference. So here's often how it's going to be given to you. It's going to be given to you as identify the first 4 terms in the sequence. The first thing I'm going to do, it wants the first 4 terms in the sequence. So I'm going to make a table. 1, 2, 3, 4. Because I want my first 4 terms of the sequence. And again, remember, these are my inputs, a sub n or f of x. These are my outputs. And again, it wants the first 4 terms here, so I'm going to go ahead and just already draw my table because I know that I'm going to need that. Again, up here is x, and down here is a sub n or f of x. Okay, so my common difference right here is 3. My first term is 4, so this is set. Now when I go to my next term, my difference, I add 3. So 4 plus 3, that's 7. To find my next term, I add 3. 7 plus 3 is 10. I add 3 to find my next term. 10 plus 3 is 13. So this is how I fill it out. You saw like the majority of my work here was just writing out the table. 1, 2, 3, 4. X's and a sub n. Once I got to the actual math, I'm just adding 4 plus 3, 7 plus 3, 10 plus 3. I would go 13 plus 3 if I needed the next term. Okay. And if it got complicated at all, I would just use Desmos to do the arithmetic for me, just to double check myself. So here, again, same thing. This is just saying previous term. Okay. And my difference here is -2. So I'm going to subtract 2 every single time. Here, my first term is 10. So I go over here and I write 10. 1, 10. And then I would go to my next term. I'm subtracting 2. 10 minus 2, that's 8. Next term, minus 2. 8 minus 2, that's 6. Next term, subtract 2 again. 6 minus 2, that's 4. So that's all I'm doing for these arithmetic sequences, okay? I'm just taking a piece away every single time. So when we have an arithmetic sequence, one of the common things that we're asked is identify the first 4 terms. So this is your notes for recursive formulas and arithmetic sequences.